Welcome to our lecture online. In the previous two videos, we saw that the reflection coefficient is very tiny when the step potential is 1/4 the energy of the particle. So what's going to happen when the step potential now becomes half the energy of the particle? Will there now be a larger percentage? The answer probably yes, but how much larger? Is it significant? And also, let's try to find a more fine-tuned or more simplistic form of the equation that's easier to work with. So let's go ahead and try to develop that as well. So first, let's go ahead and plug in 1/2 E for V sub naught and see what that looks like. So this becomes equal to the square root of E minus the square root of E minus 1/2 E, all divided by the square root of E plus the square root of E minus 1/2 E, quantity squared. And now, when we simplify that, if we factor out a square root of E from here, and here, and then cancels that out, that becomes equal to 1 minus the square root of 1 minus 1/2 over 1 plus the square root of 1 minus 1/2 quantity squared. And this becomes an easier equation to jump to right away, so we don't have to go to this part anymore, by simply realizing that this here is the fraction of the energy that the potential step has relative to the energy of the particle, which is the number that goes in the equation right here. So that's the same number right here. If the fraction is 1/4, we put 1/4 in there. If it's 3/4, we'll put 3/4 in there. So it becomes a lot easier in order to calculate the reflection coefficient. All right, so let's go ahead and work this out. So this becomes equal to 1 minus the square root of 1/2 divided by 1 plus the square root of 1/2. Let me rewrite this a little bit. 1/2, so it's clear. Quantity squared. And let's go ahead, actually, this is equal to 1 minus 7.707 divided by 1 plus 0.707, quantity squared. And so that would be equal to, R is equal to 0.293 over 1.707, quantity squared. And now let's go ahead and grab a calculator and do that. So 0.293 divided by 1.707 and square that, and we get 0.0295 roughly. 0.0295, which means it's 2.95%. So the percentage of the particles that get reflected is now almost 3% versus about a 0.5% when the potential was 1/4 the energy of the particle. Now that the potential step is 1/2 the energy of the particle, the amount of particles being reflected is almost 3% of the particles, which means that the transmission coefficient, T, which is equal to 1 minus R, is going to be 1 minus 0.0295, which is equal to 975. That would be equal to, not quite, 2.95. That would be 9705. That's right, 05, which is equal to 97.05%, which is the percentage of particles that will get transmitted. So that's kind of a surprising result, with the potential step being half the energy of the particle, only about 3% get reflected, 97% still get transmitted. So let's go ahead and do one more example where now we get closer and closer, where the potential step will get larger and larger. We'll approach the value of the energy of the particle to see what will happen in the end. So stay tuned and we'll do one more example like this. Now, of course, we have a simplified equation to work with. And that's how it's done.